I'm Patrick Oury from Cadence. I'm verification application engineer. I'm going to talk to you today about technology called software-driven verification IP. The motivation of it comes actually from system integrators that want to integrate a specific IP into the system and make sure that it's functionally correct. So if we scheme an oversimplified view of what the system is, we'll find at the backbone of the system an interconnect. Then we'll have the CPU subsystem and memory subsystems. And then the piece of the IP that people want to make sure is well integrated. So it could be any kind of IP. Let's take USB and PCI Express as an example. So typically, to make the integration of this kind of IPs, we would use a VIP in front of the interface. So you will have, if this is a host, then you will have a VIP device. And for PCI Express, if this is a root complex, you will have a VIP, which is an endpoint. And software-driven verification IPs in Cadence is actually a layer we put on top of certain I/O VIPs that allows you to control those verification IPs from the software. So there are two layers. One is called VAL, which stands for Verification Abstract Layer. And then there is another sublayer, which is VRI, standing for Virtual Register Interface. So the first one is actually a set of methods that allow you to control the verification IP from the software point of view. So typically in a system, you will have methods like something like initialize the system, so starting the clocks, waking up the PLLs, doing the reset, all this kind of stuff. And then you will have the initialization of the IP itself. So if we are talking about USB, it would set the power mode, the speed, and whatever. And typically, you will have something like VIP, and then send a command, like send transfer, or if it would be for PCI Express, it would be like a memory write or memory config. This VAL is actually providing a set of methods that allows you to send commands at the VIP, so you have synchronization between the whole system and the VIP execution. And this sublayer, the register interface, is actually because we are splitting all of the commands into register access so that you can see them passing in the interconnect, and the verification IP is actually memory mapped and recognize the order that comes to it to send the proper command at the proper time. Some details on the implementation. First of all, since we are dealing with C code and C methods, we don't care about what the CPU, how the CPU is implemented. It could be an RTL, it could be a memory model, it could be a TLM model, sorry, an abstract model. And also, there are some people using this technology that are interested in being able to synchronize only with the system and then send completely random traffic. So they have a split between this set of methods that just wakes up the VIP, and then the VIP can send random traffic and be controlled by a UVM sequence, for example. And the last point is that there are some VIP that don't have those VAL and VRI layers, but since the Cadence VIP have a systematic API with control registers, we can always find a way to layer some software on top of the VIPs. So there are many different implementation details that I will skip now, but I just hope that you are interested in the concept, and we'll look forward for the next video. Thanks for watching.